Welcome to this video. We're going to be talking about the slopes of parallel and perpendicular lines. So a brief overview, the graphs below display lines that are parallel and lines that are perpendicular. The question is, what is true of their slopes? Well, when you have two lines that are parallel, you actually have two lines with the same slope. They will never intersect. When you have two lines that are perpendicular, the slopes are negative reciprocals. In other words, they form a right angle, but when you actually talk about the numbers, they're negative reciprocals. So 2 would go to negative 1/2. 3 over 2 would go to negative 2 over 3. You flip it and then you change the sign. Negative 5 over 4 will go to positive 4 over 5. Now, when dealing with the slope of parallel and perpendicular lines, it's important to know the equation of a line. And so we have the main equation we're going to deal with, which is slope-intercept form. So it's y equals mx plus b. M here is your slope, your rate of change, how steep the graph is, and b is your y-intercept, where does the graph cross the y-axis. Sometimes though, the equation of a line will not be written in slope-intercept form, it will be given in a different form, particularly standard form, which is looks like this: ax plus by equals c, where a, b, and c are just numbers. And you need to know how to change it into slope-intercept form. So it's 3 steps. First, move the x term to the right-hand side of the equation, then divide both sides of the equation by the constant b, and then simplify any fractions. And we're going to try some examples. The lines represented by the equations 3y minus 9x equals 15 and y equals 3x minus 7 are parallel, perpendicular, the same line, or neither. So we need to determine that. First, we'll notice that this equation, 3y minus 9x equals 15, is not in slope-intercept form, so let's change it. First thing we do is move the x term to the right, so I'll do that by adding 9x on both sides. So that gives me 3y equals 9x plus 15. From there, I need to do step 2, which is to divide by the constant in front of the y, so in this case 3. And that gives me y equals 9 divided by 3 is 3, and 15 divided by 3 is 5. So my equation here is actually 3x plus 5. Now my other equation was y equals 3x minus 7. So now let's look at the slopes. The slope of this equation is 3, and the slope of this one is also 3. These slopes match, which means these two lines are parallel. The lines represented by the equations 8y plus 12x equals negative 16 and y minus 2/3 x equals 9 are parallel, perpendicular, the same line, or neither. So we're going to do the same process here. We're going to start by changing this standard form equation into slope-intercept form. So I'm going to subtract 12x on both sides, and that gives me 8y equals 12x and 16 don't combine. I just write them next to each other. Then I need to divide both sides of the equation by 8, and that's dividing every constant term, 12 and 16. So I get y equals negative 12 over 8x minus 16 over 8. And we can simplify this a little bit more. 12 over 8 can be rewritten. Both are divisible by 4. That's negative 3 over 2. And then 16 is divisible by 8. That actually gives you 2. Okay, so let's compare that to my other equation, which was y minus 2 over 3x equals 9. And actually this one is also in standard form, and I need to change it to slope-intercept. But it'll be a little bit simpler. All I got to do is move the 2/3 x to the right, and I get y equals 2/3 x plus 9. Okay, now I can look at the slopes. Here, the first slope is 2/3, and the other one is negative 3 over 2. Those are negative reciprocals, so these two lines are perpendicular. And that's it for this lesson. So go ahead now and try some practice on your own.